We are talking about the extrema on a graph. Have you ever heard that word before? Probably not. It's actually not even like if you type it in your computer, it's going to say it's not a word. It's a math term that just means multiple extreme values. But in the English language, when we're talking about an extreme, it's normally there's only one because it's like the most extreme or the biggest or the highest or the lowest, right? When we're talking extreme, you're not like, hey, all of these are extreme because then it kind of defeats the point of it being extreme. In math, though, we can have multiples. We also can talk about, as you can see on the screen, absolute max or absolute min, local max, local min. So we can have multiple high points or multiple low points. So instead of just calling them the extreme values, if we're talking about all of them, it's like the plural of extreme, which is extrema. So it's just, like it sounds, the extreme values. So when we talk about our extreme values, we can have what is called the absolute max. And just like it sounds, the absolute max is the highest point on the graph. It's the highest point on the graph. You actually physically have to be able to like put your finger on that point in order for it to be an absolute max. So you can't tell me the absolute max is a point at infinity. If it's something that's going up forever, it's not going to have an absolute max because it doesn't physically, it can always get higher, higher, higher. It can only have an absolute max if you can physically touch the highest point on the graph. Cannot be infinity. So, for example, something that looks like this, our standard parabola that we're used to seeing, oh, you cannot see that color at all. Our parabola. Both of those sides, both ends are going up forever, so that's not going to have an absolute max. It doesn't have a highest point, because no matter how high I go, I can always go a little bit higher. Whereas if I took my parabola and I tipped it over, now I have a highest point right here. So my absolute max, I can physically touch the highest point on the graph. I have an absolute max there. Absolute min, lowest point on the graph. Same thing, you have to physically be able to see that lowest point. It can't be something like negative infinity. You have to be able to pinpoint it. So if you're ever tempted to give me an answer of negative infinity or positive infinity, the actual answer is it does not exist. Something like our standard parabola has an absolute min right at the bottom, whereas when I turn it over, there is no absolute min here because it's going down forever. So now your absolute max and min have to be the highest or the lowest point on the graph. Your local max and min are just going to be relatively high points or relatively low points. They can also, instead of being called local max or mins, they can be relative maxes or relative mins. So, aka relative max. And this is also can be a relative min. So sometimes they may refer to it as finding the local max, or they may ask you to find the relative max. Both mean the same thing. Anytime you're looking for a local max, it's any high point. So in a polynomial that has multiple ups and downs, anytime you're at like the top of the hill, that would be a local max. So in a situation where you might have something that goes like this, every time you're at the very top, those are all absolute maxes. Anytime, so the really unmathematical way of describing it is the top of a hill. The mathematical way of describing it is it's anytime the graph is switching from going up to going down. So see how every time I picked one of those local max points, the graph was going up, and then right at that local max, it started going down again. So if it's switching from increasing to decreasing, that's a local max. From positive to negative. So anytime the graph is changing from being positive to being negative, that's a local max or a relative max. Relative min is exactly the opposite. It's those low points, or like bottoms of valleys. They almost look like if that was a big mountain range. So your relative min, when I'm dealing with something like this, your relative min is any of these low points. So unmathematically, they're like valleys in the graph. Or it's where the graph is switching from being negative or going down to going up. So absolute, very highest or very lowest. Local, all the high points. Local min, all the low points. When you tell me the location of these, you're always going to use the x value. So I don't care what the y value is whatsoever. If you're telling me the location of an absolute max, an absolute min, a local max, a local min, any of the extrema, you're always using the x values. So you are always using the x values to tell me the location. The other somewhat helpful way to think about this is if you look at this like it's a roller coaster, or if you take all of these graphs and kind of think about them as if they were a roller coaster, you're always reading them from left to right. So it's like if I was hopping on the roller coaster here and traveling along and going through, I'm always going from the left side over to the right side whenever I ride that roller coaster. So if I want to say the absolute max, the highest point on that graph is going to be up here. That would be my absolute max. So I'm just going to give myself more room. My absolute max is the highest point on the graph. My absolute min is the lowest point on the graph. Now, in this situation, my absolute min and my absolute max also happen to be local maxes and mins. So they can double as more than one. Even though this is the highest point on the graph, even though right here I'm at the top, there's nothing that goes any higher, it's also a place on the graph where the graph is switching from being positive to being negative. So because that's happening, this is also considered a local max. So you can use the same point, could be multiple things. Same thing here. This is also a local min. Because anytime my graph is switching from going down to then going up, I've got a local min. It also just happens that it is the very lowest point on the graph, so it's also the absolute min. So far, so good? All right. Let's ditch these roller coasters and use some real graphs. So if I give you this nice, beautiful polynomial, and I say identify the extrema, I'm now asking you to find the absolute max, the absolute min, the local maxes, and the local mins. So anytime I see a problem like this, the first thing I would go in and do is probably write down, okay, I want my absolute max, I want my absolute min, I also want my local max, and my local min. So I have to find all four of those things when they're asking me to find the extrema. So now I want to look at my graph and I want to say, okay, do I have a highest point on this graph? Can I physically put my finger on the highest point of this graph? No, right? Because my graph, this arrow tells me my graph is going up forever. So I don't have a point that I can physically touch that's going to be the highest. So I do not have an absolute max. You can write none, or you can write does not exist. Does not exist, which is in math DNE, right? Either one of those work. None, DNE. Do I have an absolute min? Do I have a lowest point? No, because now I have an arrow over here going down forever. So I also don't have an absolute min. Do I have a local max? Do I have multiple local maxes? Yes, I can see 2 points where I have like the top of a hill, right? Or where I'm going up and then all of a sudden that roller coaster is going to shoot down. I have 2 places, one right here and one right here. So when I write this, I'm going to say at x equals -3 and -2 because I don't care what the y values are. I just want when x equals -3 and -2. I only want my x values. What about my local mins?
Yes.
Where? Perfect. Yes. I have local mins at -1 and 4. So I would say x equals -1 and 4. Not too bad? What if I gave you a graph like this and said identify the extrema? Now I notice right off the bat this graph has endpoints, it doesn't have arrows. So because it has endpoints, that tells me I have to have a highest point and I have to have a lowest point. So I'm going to have everything here. I'm going to have, let's see, I need my absolute. I need to find all of these, right? I need to find my absolute max, I need to find my absolute min, I need to find my local max and my local min. Where is my absolute max? At 7, right? My highest point on my graph is right here. So I would say at x equals 7. X equals 7 is my absolute max, the highest point I can physically touch it. What about my absolute min? Where's the lowest point on my graph? Just at 1, right? I don't want to say -11 because that's my y value. I want to use my x value, which I think is the hardest part to get used to because you're used to telling me, oh, the lowest number, -11, that's the smallest number on there, right? But I physically don't care how low it is. I just care where the lowest point is. So I'm saying my lowest or my absolute min is at x equals 1. What about my local max? Any place where my graph is switching, or if it was a roller coaster where I'm going up and then all of a sudden I'm going down. So I definitely agree here, right? Because I'm traveling up and then I'm traveling down. So that's definitely a local max. I can't include 7 because I don't know if at 7, although I'm going up at 7, I don't know what's happening after that because there's no more graph. So I might not be going down. I could still be going up. So I'm only going to use 4. My local max is at x equals 4. What about my local min? I have 2 local mins, right? I have 2 places where I'm going down and then going up. 1 and 6, right? Because I'm going down, and then I'm going up here, so this is 1. And I'm going down, and then I'm going up, so this is 1. So my local min, 1 and 6.